What we're going to be doing today is finding the coordinates of a point on a curve when you're given the actual gradient at that point. So to illustrate that, if I were to draw a curve, so there's a happy shaped quadratic curve, and let's say there is some point on this curve such that the actual gradient at that point is, say, 4. So what that means is that the tangent to the curve at that point has a gradient of 4. So what we're saying is we're given the actual gradient at a point on the curve, but we don't know the coordinates of the point. Now what we do is we differentiate the curve to get the general gradient at any point, and then at the point we're investigating you set the general gradient equal to the actual gradient. You will solve that equation to get the x coordinate of the point. Once you've got the x coordinate of the point, you will then sub it into the curve to work out the y coordinate of the point. So that's just a bit of theory. We're now going to apply that to our first example. Okay, so our first example says, find the coordinates of the points on the curve y equals x cubed minus 2x plus 7 where the gradient is 1. So find the coordinates of the points in this curve where the gradient is 1. So this is the actual gradient at 2 points on the curve. Okay, and we want to get the coordinates of those points. So the first thing we do is we work out the general gradient at any point on the curve. So we're going to get dy by dx. So general gradient so we're going to differentiate the curve. So that's going to give us 3x squared. We're just going to end up here with minus 2. And then remember, when you differentiate a number term, it just disappears. So this is the general gradient at any point on the curve. What we want to do is get the x coordinate of the unknown point. So I'm going to put a title x coordinate of the point. Now the x coordinate of the point is found by setting the general gradient equal to the actual gradient. Okay, so we set dy by dx equal to 1. So we set the general gradient equal to the actual gradient. So we're going to set 3x squared minus 2 equal to 1. And then we're going to solve the equation we're left with. So plan then, because there's only one x squared term, what I'm going to do is I'm going to just get the x squared term by itself and move the minus 2 to the other side. So we're going to get 3x squared equals 3. I'm going to divide through by 3. So we're going to end up with x squared equals 1. And then we're going to take plus or minus the square root of the other side. So we're going to get x equals plus or minus the square root of 1. So that's just going to give us plus or minus 1. So what does that mean? We've found two x coordinates. What that means is there are 2 points on the curve such that the gradient, the actual gradient of the tangent is 1. Okay, so there's 2 points in the curve where the actual gradient is 1. So what we're going to do now is get the y coordinates of these points. So we're going to sub the x coordinates of the points into the curve because they lie in the curve. So we're going to get y coordinates of the points so we sub the x coordinates into the curve. So let's take the first x coordinate, which is minus 1. So when x equals minus 1, chuck it back into the curve. So replace everywhere you see x with minus 1. Okay, so that is going to give us minus 1 cubed is minus 1. That's going to give us plus 2. So minus 1 plus 2 is going to give us 1. 1 plus 7 is going to give us 8. So there's one of the points. So one point is minus 1, 8. We're then going to sub in the other x coordinate into the curve. So we're going to chuck in x equals positive 1. So we're going to get y equals 1 cubed minus 2 times 1 plus 7. So that's going to give us 1 minus 2 again is just going to be minus 1, and then minus 1 plus 7 is going to give us 6. So our other point is 1, 6. So we'll write our answers down. So answer points are minus 1, 8 and 1, 6. Now, what I'm about to do, we've answered the question, but what I'm about to do is draw a sketch of what's happened. You don't have to do this, but I am purposely doing this to get you to appreciate what's just happened. What we had at the start was a cubic curve. Do you notice the coefficient of x cubed is positive and there's more than one x term? So this is going to be a cubic curve with shape that goes up, down, up. So what I'm going to do is just draw a little sketch. So it's going up, down, up, something like that. And the question asked us to find the points on the curve where the actual gradient is 1. So what I'm going to do is I'm going to draw a tangent to 2 points on the curve where the actual gradient is 1. So let's say there's a point there, because if I were to draw a tangent at that point, the tangent would be sloping up. So there's a point where the actual gradient is 1. And then I could also plot a point somewhere over here. And if I rule a tangent through that, the actual gradient at that point would also be 1, because the two tangents would be parallel. And what we've actually done is we've worked out the coordinates of those points. So one of them has coordinates minus 1, 8. So that's going to be the point further over to the left. Its x coordinate is negative. And then over to the right, this is our other point. That's the point 1, 6. Now, maybe I could have put that point a wee bit lower down, but it doesn't matter. You can see clearly there from the sketch that it all makes sense. So, in summary, to find the coordinates of a point on a curve when you're given the actual gradient, what you do is you differentiate the curve to get the general gradient at any point. You then set the general gradient equal to the actual gradient and you solve that to get the x coordinate of the point or points, and then you sub the x coordinate or coordinates into the curve to get the y coordinates of your point or points.